Hello ladies and gentlemen, welcome to another stats lesson. This lesson is about confidence intervals, and in this case we're talking about means. So let's just get started with a problem and see how things go. In this one, an auto parts manufacturer has to be reasonably precise when it drills holes in its parts. To test the precision, an inspector randomly pulled 25 parts off the assembly line. He found that the mean of the drilled holes he measured was 1.248 centimeters. The sample had a deviation of 0.057 centimeters. What does a 95% confidence interval say about the size of the drilled holes? Well, let's investigate this a little bit further. One of the things that we're going to need is T star. Since I like to find T star from the calculator, let's identify some of the parameters for this. Anytime that you're talking about T critical or T star, what you really want to think of in your mind is a normal curve, and you're trying to figure out exactly what is the percent confidence that you want between your interval. In this case, we're wanting 95. So as this picture is showing, 95% of the data should fall between those two arrows that I've showed you here. That means that 2.5% of the data is on that little left tail, and another 2.5% is on the right tail. The degrees of freedom is a formula that's given by n minus 1. And in this case, since we're using 25 for n, then the degrees of freedom is going to be 24. So taking a look at this arrow right here, the actual percentage of the area that is below this is the 95 plus the 2.5 found in this little tail, or 100 minus the 2.5 found here. So this is about 97.5%. Next thing I like to do is to identify my variables. X bar is 1.248. That's the mean of the sample. T star is going to be 2.0639. Haven't exactly showed you where that comes from, but I'll show you that on the calculator in just a moment. S sub x, which is the sample deviation, was 0.057. And the square root of n in this case is the square root of 25, or just 5. I promised you that I'd show you where the T star came from, so let me pull up the calculator and I'll show you that calculation. Alright, now that I have the calculator up, what I was wanting to show you was how to calculate T star or T critical. That is under second, vars, and if you go down the menu list, you'll notice that number 4 actually says inverse T. A little bit too far there. So while you're on number 4, just click enter, and it'll actually ask you for the correct numbers. Obviously this calculator has had some other numbers in it. The nice thing is that we were wanting 97.5 as well, so 0.975, enter that. And for the degrees of freedom, this time we were using 25. The degrees of freedom calculation is 25 minus 1, or 24 in this case. Pressing enter again. One more enter will paste it to your main screen, and if you hit enter one more time, it will actually calculate it for you. In this case, T star is 2.0638 with a 9854. You can keep going on with decimals and decimals. As you noticed in the examples, I cut it down to 4 decimal places, so that's what we're going to use in this case. So let me just get this calculator out of the way and we'll continue with the example. Now that I've got the calculator out of the way, let's take a look at the rest of this calculation that we were working on. Again, there's the formula x bar plus or minus T star times the sample deviation divided by the square root of n. So when I'm filling in a formula, I like to just take all the letters out and write everything else down before I plug things in. That way you can actually make sure that you're getting them in the right spot and you're not putting things in the wrong places. X bar was 1.248. T star was 2.0639. S sub x was 0.057, and the square root of 25 since n was 25. Doing that calculation, you get 1.248 plus or minus 0.02353. And when you add 0.02353 and subtract 0.02353, you get an interval between 1.2245 and 1.2715. Well, those are nice numbers and all, but what do they really mean? What it's really telling you is that within 95% of the data, 1.22 is the approximate measurement on the lowest end, and 1.27 is the approximate measurement on the highest end. So the holes kind of range in between there. Some things that you should probably think about from this data. What does this really tell you about the holes? What do you think the target size of the hole was, or what was it supposed to be? Or what was the measurement that they were trying to make the hole size? And given the range of possible sizes, do you believe them to actually be reasonably precise enough? And something else you might want to think about is, what other questions would you like to have answered before you ever answer the ones I've just posed to you? Just some thinking questions to get your mind working and to actually use this math for something other than just, oh look, there's the numbers. So think about that for a while and have a good day.